All right, calculus people. We are going to do a little bit more with integrals, and I know it bothers some people that there's a plus C. Kind of bothers me a little. So this section, you'll see your worksheet. The front page is really just practice on what we did for 5.1a. It's just indefinite integrals, and it'll all have plus C. But on the back page, you'll have some problems where you can figure out what C is, which is awesome. And we can only do it if we have additional information. Like if you look at example 1, be careful, look at this. It says the derivative, so f prime of x equals this, and here's your additional information. Without this, you would have to have a plus c in the problem. And we're going to find out in a second. So my goal is to find f of x. So if I start with a derivative and I want regular f of x, I have to take the integral, which you would say I integrate the problem. Okay, and there's my beginning and end, kind of like my parentheses, or you should put it in parentheses really. So on this one, you just do your rule right away. So it's a recap of what we've already known. So when I do an integral, I write it down, but I raise the power up 1 and I divide by the new exponent. I raise the power up 1, and so it's negative 1x, right? And you divide by the new exponent, which is 1, because there's a 1 power here, plus c. Now what I didn't write here, and I should have, is this is f of x. So you're going to need that. In our other problems, I wasn't writing this. If you take the integral of an f prime of x, your answer equals regular f of x. So this is just like before. Maybe I'll clean it up, right? F of x equals x to the third minus x plus c. I know I did it right if I take its derivative and it equals that. Let's see, 3x squared minus 1. Hey, 3x squared minus 1. So here's the problem, or here's the new part. I can actually figure out what c is by using this info and plugging it in. Remember, there's your x and there's your y. Okay, so in this problem, if I plug a 2 in everywhere I see an x, and I plug a 4 in for y, or f of x, then I can actually figure out what c is worth. Use parentheses, you'll be less likely to make a mistake. And then I just solve this down. Okay, so 2 cubed is 8, and then 6 plus c. c is negative 2, which means don't do all this work and then forget to actually finish the problem. The problem is I want to write this without the plus c. So my final answer is my equation was not just x cubed minus x plus a random number. It's x cubed minus x plus, well, minus 2. Okay. Is its derivative still 3x squared minus 1? Yes, but instead of having that unknown c, I use this extra bit of information to be a detective and find out what c is. And there it is. It feels much better to have that answer. Just don't leave your answer, don't do all this work and leave that, and leave it up to the other person to figure it out. Make sure you can finish it off. Put a bow on it. All right, so here we're going to take it up another level here. Let me pause this while I write the problem down. All right, so this is a cool problem because we're going to take it up a notch and it'll show if you have good attention to detail. I want you to find the original equation, hopefully without any c's. And here's the sneaky part. I'm starting you off with the second derivative. And you have to back it up with integrals twice. But luckily, you have this initial information. If you didn't have this initial information, you'd be kind of stuck. So we're going to use this to hunt down things. But let's just start with what we have. If I have this as my second derivative, and I take the integral of it, what's the integral of the second derivative? If I backed it up a step, it equals the first derivative. Okay, that's easy enough. If I go backwards a step and I take the integral, then I'm raising up the power 1, right? X to the third divided by my new exponent plus c. So far, so good. But I don't want f prime of x. I want f of x. Before I do the integral of this, I want to use my given info. Now look at my choices. I have an f prime and I have a regular f. I'm choosing this one first. I'm going to plug in a 0 for x. I'm going to plug in a 6 for f prime of x, right? Because that's my x, that's my y. It's not really a y, it's a y prime. And then I'm going to solve it. So I'm going to put in a 0 cubed over 3 plus c, and c must be 6. So this is why I said in the past, don't just stop here, because if I'm going to take the integral of this guy, I want to rewrite it as x cubed over 3 plus 6. If I had the c, I'm going to get like multiple c's in the problem, and that's not good for anyone. Okay, so now that I've done that dirty work, now I have the derivative, and if I back this up a step, meaning integrate it, this was like round 1, if I integrate of f prime, the answer is going to equal f of x, the integral of this guy. Okay, so now we're going to do our integral rule again. This time it's going to equal f of x. So when I raise this one up a power, x, it was x to the third over 3. Now it's going to be x to the fourth and divide by the new exponent. And this, I don't think I did an example of it, but what's weird is if there's already a denominator and you go to divide by 4, you're just multiplying whatever's in the bottom. Okay, like here, there was nothing in the bottom, so I went x squared became x to the third. Since there was nothing in the bottom, I just dumped a 3 down there. This time there already was a 3 in the bottom, so when I go to dump a 4 down there, I have to multiply by whatever's already down there. Raise the power up 1, so it's 6x to the first, divided by 1 doesn't do anything, and plus c. And now I finish the problem off with my other tidbit of information. Here's my x, here's my y. I'm going to plug in a 0 here and here. I'm going to plug in a 3 there. So 3 equals 0 to the fourth over 12 plus 6 times 0 plus c. Is it always going to just equal the number? The answer is yes if it's a 0 in there. We saw in our first problem the number didn't equal when it wasn't a 0 for x. So finish the problem off. Don't stop there. The problem really is x to the fourth over 12 plus 6x plus 3. That is your original equation. You can check if you're right by taking its derivative and then taking the derivative of the derivative and see if you end up with x squared. I bet you do. Alright, so it's word problem time. We're basically going to do the problem we just did, but in a word problem, which is kind of cool. So you got a lump of coal in your stocking this year. Frowny face. I should probably put a frowny face here. Wah, wah. In a fit of rage, you open the window and hurl it upward in the air from an initial height of 20 feet. So you're like on the second story. You launch the lump of coal upward at an initial velocity of 64 feet per second. Write an equation for the height of the coal. Assume gravity's acceleration is negative 32 feet per second squared. So basically what you have to remember, if you remember how to set up your equations with the negative 16t squared and all that stuff, then you're cool. But what's nice about this is you can see, even if you forgot all that stuff about our acceleration problems and the formula we memorized, we can do this problem. You can do it with this whole integral idea and initial value. So as long as you remember that height was your normal equation, the derivative of that, is velocity, and the derivative of that equals acceleration. Well, what's that mean? Well, if I start with acceleration, I'm starting with double prime, and I can take the integral to go back to velocity, and I can take the integral of that to go back to height. So I really only have to start off with this. So if I start off with this and I take its integral, I'm going to end up with a velocity function because I'm here, and if I integrate it, I go to velocity. So the integral, so v of t, is going to be the integral of -32 dt. I'm matching my letters, vt dt. So this is an easy one, right? I'm going to integrate a -32, which you just add an x, although this time I'm going to add a t because, well, we're not using x's here. And you need a plus c because you didn't know the derivative of this could have any constant here. Here's where you go back in the problem and hunt. It's kind of like in this problem, I started with the second derivative, and after I took its integral, I was with the first derivative, but I had to go hunt for information about my first derivative to find what c was. Same deal here. I need to find information about my first derivative, also known as velocity, in this problem. How about that? Well, look, they gave me something interesting. Initial velocity means when time is 0, then my velocity is 64 feet per second. So you can come back here and plug the 0 in for t and the 64 in for v of t, and we can find our initial c. 64 is -32 times 0 plus c. c must be 64. So in this problem, oh, we don't have squared anymore. In this problem, we know that our velocity function isn't just -32t plus c, it's -32t plus 64. And then I can take the integral of this, because now I'm here and I want to get to a height function. I can take the integral of my velocity function and it's going to equal my height function. There's my integral symbol. I'm going to take the integral of -32t plus 64 dt, because I want my letters to match. That's like my beginning and end. And my function is going to look like this. Raise the power up 1, so it's t squared, divide by the new exponent, and then I raise the power up 1, and then I need a plus c. So my height is going to be this equation. I'm going to clean it up a little because I know what 32 divided by 2 is. 16t squared plus 64t plus c. Now I wish I knew what this c was if I only had some information about my height. Oh, look at that. Initial height of 20 feet. That means at time 0, height is 20. So I'm going to plug in 20 for height, and I'm going to plug in a 0 for time. And I'll find my final answer. And, oh, sorry, a 20 for height and a 0 for time in both places. And you'll find your starting height is 20, your c is 20, so my final answer is h of t equals -16t squared plus 64t plus 20, which, if you remember when we set up problems, it was gravity, initial velocity, initial height. That's where these equations come from. They don't come from a magical place. They're just, they're because of integrals, and we never knew integrals before, so we kind of just told you how the equation worked. But every one of those equations we wrote could have started with acceleration, take the antiderivative, plug in your initial value, take the antiderivative again, plug in your initial value, and you get to that. Isn't that crazy? All right, so hopefully you understand initial value problems a little better. Basically, you can get rid of the plus c if you have other information to plug in. All right, I'll talk to you later, people.